Alright, welcome to Lab 1 in CPIT 252. This lab presents an overview of object-oriented programming concepts. So the goal of this lab is to provide you an overview on the concepts in object-oriented programming. We will get started. Just make sure that you have these requirements. There is a link to the lab content in the description and the course website. So make sure that you have JDK 8 or above. We're going to be using IntelliJ IDEA and JUnit 4, right? So to get started, please clone and import the starter project. There is a link here. So if you go to the starter project, you will find a link to the repository. So make sure you download this or clone it and then import it into your IDE. If you have received the link to the GitHub classroom, you must accept the assignment. So find your name in the list and then click on your identifier or your name. And then you have to link the name, your student name, into your GitHub handler, right? So if you have received the link to invitation to the assignment, you should not go directly to the starter and clone it. Instead, you should use the link in that you received on GitHub Classroom. And then from there, you will fork it and make sure you check the deadline or the due date for the submitting the assignment, and then you basically will be able to clone it, and then once you clone, you click on the link, and then you will have the starter project under your own repository, right? So this is the link. And then from here you can just go ahead and clone it. So copy the link to the repository on GitHub. So copy this, and then you will need to clone it using Git. Right, so I'm going to open up the terminal app and then just git clone it. Right, so now we cloned it into our directory or folder. Now I'm going to open up IntelliJ IDEA and import the project. Right, so click open. And then find the path to the project that you just cloned from GitHub. Open it, trust the project. So once we open it, I'm going to take a look at the src directory, and we can see all the class files of this lab, right, for this lab. So this is the product class, and this is this is the pom.xml file with JUnit version 4. So the first one is instances and class variables. We're going to look at the difference between the two. So here's the product class. The product class is already here. I don't need to copy it. It looks exactly the same as the one on the web page. So we're going to move into the next one, which is the main class. Main class, we're going to make sure that it looks exactly the same. Sure it does. So the first questions, as you say, compile it, run it, you're obviously going to get a quantity 1. How would you fix this code to print the correct total quantity of 3? Right, so we've instantiated 3 objects, product P1, P2, P3. When we print the quantity, we call get total quantity, we do not get 3, we get 1 instance. So the reason is because the quantity is an instance variable. So each object, instance of this class, will have a copy of this variable, right? So they will have a copy that is independent from other objects. So we need to make it shared by changing it from an instance variable into a static or a class variable. When we use a static, we do not want to use this, right? Because this will also always refer to the instance. So I'm gonna change it to static and remove this keyword from the quantity global variable. All right, so it looks good. So now let's run it. And we got 3, right? So that's why the reason why we got 1 is because it was instance variable. Now it's a class variable. Class variables are shared among all instances, right? So moving on to the next one. The next one is testing with JUnit 4. So we're going to use JUnit 4. I'm going to check my pom.xml, make sure I have the dependency for JUnit 4. Sure it does. And then we're going to add a product test, right? So we're going to look at product test class. Make sure it's there. And it looks like it is there, right? So let's run this test and see what's next. It says you want to run this unit test. So right click, or you can just run it, either right click on it, or you can run it from just hovering over the class name, or you can just run the method itself, right? So run the class. Now we're getting errors from the other test, lab test, because we still have not implemented all the functionality of this lab. So I'm just going to go ahead and comment this one out. At the end of the lab, I will uncomment this class. So make sure that you comment this and then go back to it and uncomment it when we are done, right? So now this should do it. Let's run and see. And we get the green check, right? Sweet. So now the test is running, and we were able to run our unit test and making sure that we have 3 quantity, right? So let's move on to the inheritance, number 3. So we're gonna extend these 2 concrete classes. We're gonna go to the we have electric and food product. So if we go to the food product, we want to extend the product class, right? Let me just go ahead and copy the whole code here. And paste it here. Make sure you keep the package name. We don't want to change the package name, so move to the electric product and copy the content of this class and then paste it here, right? Make sure we add this to the main class. So just gonna go ahead and copy this and then place it under the last line in my main method, right? So instantiate a product and food product and electric product. So the question will say the product class should not be instantiated directly. So that means we do not want a new products, as you see in line 13. We don't want to instantiate the instance. All right, so now we run this. This is running. Now we want to make sure that this class, product class, should not be instantiated directly, right? So you have to create instances of the concrete types, the food product and the electric product. To do this, we need to go back to the product class, and we need to make this class abstract, right? So once it's abstract, we will not be able to create instances directly from the product class. Let me look at the methods, if there is any method that probably makes sense to make it abstract method. Let me see. Yeah, it looks like get syllable status. We need to leave this the implementation of this method to the subclasses. So I'm going to change this to abstract method. Right, so I'm gonna leave the implementation to the concrete classes. So make this abstract. When it's abstract, we need to remove the body of the method because we're gonna leave the implementation to the subclasses. This looks good now. We go to the electric product now. We need to implement the abstract method. So I'm gonna just keep the same implementation for now. So we need to override that abstract method in the parent class. So public void get, and let me just make sure the name is correct. Let me get the yeah, it's get syllable status. Right, I'm gonna keep the same message. We can change it later, and then I will have to do the same in the food product class. I'm just gonna go ahead and copy this, go to the food product. Obviously see the error because we have not implemented that abstract method. So now the error is gone. So we'll save this. This is the change that we made to the definition of the product class, right? So now these are all errors, right? So we cannot create directly instances of product. So we change this to the concrete types, the subclasses. So this all looks like food products to me. So I'm gonna keep the variable type, the generic type, the product for the super class, and then just change the instance type to the concrete ones, right? So now it's food product. That means we need to add an additional argument for the expiration date, right? So I'm just gonna go use the local date, I believe, class, and then parse a string, call the static method parse, and then give it a string of date, right? So I'm just gonna put some random dates for all these 4 instances. We'll do the same for our unit test. This is food product, and this is also food product, and then we need to add the local date dot parse. Right, so save this, run it, make sure our test is still passing. Great, getting the green check. And then we're gonna run our main class. On the main method we got 3, so things now are working after making the product class an abstract class. So we need to move to next, number 4, polymorphism, many forms. So we're asked to use the for each loop in Java. So we're going to create a list of products and then we iterate through them and then print the content. Right? So we already have a number of objects here. So I'm going to make an array of product, the parent class type, and then inside the array I'm going to put all these objects, right? So P1, 2, 3, and 4, and 5. Need to rename this to 4, and then change this to 5, and then looks like we have 6, right? So I'll add the 6th instance. All right, now we're gonna loop through them. So we put parent type, superclass type, and then we iterate through them using the for each syntax. Right. So this is how we can do this iteration using polymorphism by referring to the parent class. So we don't need to use the concrete classes types, right? Just refer to them by their parent class product, and then we can call the same toString method for all objects, right? So that was for number 4. Number 5, we're going to move into controlling changes. So we have a method, and this method, it says we want to prevent anyone from changing this method, right? So to prevent overriding a method, so the method can be changed through overriding, we basically need to change it into final, right? So this is the method that we want to prevent add to shopping cart. We want to prevent subclasses from overriding it. So if now I go to the concrete class, I will be able to override this method. Public void add to shopping cart. So inside my food product, I was able to override that method and change it, right? So what should we do to prevent subclasses from changing it is basically we change it into final. Right, so now it's final, save it, we're getting an error. That error is because this method cannot be overridden, right? We cannot change this method in any of our subclasses because it's final, right? So we have to remove this and then save it. And this will do, and now the error is also gone from the product class. Right, so that was number 5. So without changing the visibility, so I did not even change the visibility, so they're still public. So the class is still, the method is still public. So right. So number 6 is abstraction. So we're gonna add order information. So to the product class. Order ID, order status to the product class, and says why is this considered bad, how would you fix it, right? Well, this is bad because this is not an order class, this is a product class. If a class is doing too many unrelated things, that is considered a very poor abstraction, right? So we don't want to add any thing that is not related to the product, not directly related to the product inside our product class. So ID, price, name, quantity. So we're going to create a class called order, right? We don't want to put the order information inside our product class, right? So create a class order, and then I'm going to generate the pouring constructors and getters and setters. So generate the constructor, and then I'm going to generate the code, and then go to generate, and then select getter and setter, and then select all the fields. All right. So now we have the order class, right? So this makes our abstraction better, because the product class will only do one thing, and that thing is just related to the product, right? So let's move on to number 7, encapsulation. We're going to add a new property, weight, to the product class, and this one is public. All right, so it's not private, it is public, because we're going to look at encapsulation. So public double weight, right? I'm going to add it to the end of the constructor. And then so now it's still public. That means we can change it from the outside class. So if I go to my app class, the main class, and then I can now have direct access to this property, right? So P1, any instance that weight, I can set it to a negative, which is wrong. So now it will accept an invalid value, right? Because it's open and accessible from the outside, right? So this is considered bad, because the class itself, product, has no control over the valid values for this property, right? So we need to change it to private, and then add a getter and setter for this property. So I'm going to the end here, and then I'm going to add a getter. All right. So I'm going to return this dot weight. And then I'm going to add the setter. So here we can check for the value, right? So if getting something negative, we can reject it, or we can throw an exception. So if weight is less than 0, I'm going to throw an exception, right? New illegal argument exception, right? And then I'm going to say invalid value. All right, so invalid weight value as the message. We can just return, right? I always like to return, throw an exception. So this did weight, and then we can set it if it's a positive number, right? So we save it now, and then go to the app class. Now this is not possible, right? Because it's private, so it has to be set through the setter. So we do P1 dot set weight. Now if I give it a negative value, an invalid value, and run it, I should be getting an illegal argument exception. All right. So getting here an error because I forgot to add pass the weight to the parent class, since the parent class now has the weight, right? So this is another side of inheritance, that if you make changes to the parent class, you're going to break all the concrete classes, right? So this is called tight coupling. So I'm going to add the weight to the parent, to the concrete classes, right? And pass them to the super class. I'm going to add it after name, so double weight, and then pass it inside the constructor to the superclasses constructor. Right, I'm getting also errors here. I need to also add weight information when instantiating an object of these concrete classes, the food product or electric products. I'm gonna just put some random weights in grams here to all these objects. So this is a cheese, probably 270 grams of cheese, and this is an electric extension cord. So I'm going to put 210 gram, and then I think this looks good, so save it. Let's run it now, and let's see if we're getting that exception. Right, great. So we got the illegal argument exception, invalid weight value. All right. So now we have check mechanism on checking the valid values for this property, because it's a private, and we can put the logic inside the setter. Right. So if we put a positive, it's working. So this is great. All right. So this was for encapsulation. And we saw that why this is considered bad. The user setter is very important to add checking capabilities to the valid values, right? So it looks like we have implemented all the 7 questions. Now I need to go back to that class that I commented out. I go to the lab test, and then I will uncomment this, and I will run the test, making sure that my test will pass. So if this test passes, that means you did all all of the 7 questions correctly. So if we look, we create a P1, P2, P3, P4 before running each test. So we put it before class, we create this object, and then we check the quantity for question 1. We created 4, so we make sure it's 4, and then here we check for inheritance, and here I'm using Java reflection to check for the if that method is final, right? Some of the questions will require me manually inspecting the code, like the for each loop, for instance. Some of them are automatically graded. Some will be manually inspected, right? So let's save and run it. I'm getting an error. So let me check. Oh, I need to add the weight to my product test class. So let's put these random weights in grams. And now let's run the test. So this product test is passing now. I'm going to go to the lab test. I will run all the tests, and the tests are passing. Right? Cool. So now we get all the tests in green, passing. Now we need to submit, right? So you need to include either a PDF or a markdown with your submission, adding your name and the answers to these questions. So if you go to the GitHub Classroom and you go to the link that you received invitations to, and then we need to basically check the Git repository. I'm not inside the repository, so I'm gonna go to that folder, lab 01, and then my GitHub ID So now if I do git status, let me just pump the font. Now we see that we have these files that we made modifications and we changed them. So we need to add them to our Git repository. So I'm gonna git add. So this is a new class. It's not tracked, so I need to add it. So I'm gonna add this order class, and then I'm gonna add all the other classes, right? So if I do git status, this was added, but these that we made changes to are still not added, not staged for commit. So I'm gonna add everything. You can add them individually, one by one, or I can use just dot to add them all. All right. So git add dot and then git status. Now these changes are ready to be committed. So we do git commit. I'm gonna add a message, and in the message you can put any message. I'm gonna put completed lab 1 commit, right? So now if I do git status again, I see that I'm ready to push. All right, so git push origin to GitHub, and then main is the branch name. All right, and so I'll push it, and now I will refresh, and I want to make sure that I get green check next to my name. Right, so I had to make changes to the pom.xml in order for that test to pass. So if you open this pom.xml, you can see that I made change to the source and target version of JDK. So I made it 1.8 because that would GitHub default for actions, running these actions and grading. So I made several changes, but you don't need to make these changes. So if you click on the auto grading actions and then auto grading, and then you can click on the third one, run education auto grading at version 1, and then scroll all the way down, you should see that all tests passed, and then you should see the grade, right? Let me just pump the font here, zoom in, and then points 100 out of 100, right? So what happens is GitHub ran that test, and then when the test passed, you got the grade, right? So now if I go to my control, you'll not be able to see this. This is only for me, the instructor. You can see that I got the grade 100 out of 100, right? So if I reload, you will see, so every changes you made, the test will be run, and then your grade will be computed, right? So that's how you submit your assignment. And again, this is only if your instructor has asked you to submit through GitHub Classroom, right? So we need to add, check that README file. Need to edit that README file. I'm going to show you how to add your answers to a README file, so markdown file.md. Let me see how to edit this in IDEA. I think if I click this, yes, this is, and this is even better, right? So this is the markdown file, right? We can start editing this file. So first, you can put your name, right? So put your name here, and then you can start writing your answers, right? So we're gonna use a title. So I'm gonna put Q1, and then I'm gonna put all the answers, right? So this is how you will edit the markdown file. So you save this. And next is you need to add it to your local Git repository, commit it, and then push it, right? So git add this readme file, and then git commit. Put up a message. I'm gonna say add answers, and then I'm going to push it to GitHub, right? So git push origin main. So we push this, and if I reload now, if I go to the summary and go back to the repository, I should be able to see the readme file added, right? So you can do this, or you can add the PDF if you want in your submission outside of GitHub repository if you prefer. So that's how you do lab 1, right? Thank you.